going to be the last section for today. We're going to leave off on pointers, and this video is just going to be a really brief overview of everything we kind of covered with pointers, mostly. So how they work. You create a pointer, and it's a variable, right? And it contains information. And the information it contains is 4 bytes, and the 4 bytes is a value that actually would be something like this, 0x123, a hexadecimal value. And what that represents is an address in memory that actually points to, so if we follow this line, the address over here for a variable called var1. So this is our int var1, and it has a value of 100, but its address in memory is 0x123. When we create this pointer that points to an int, and the pointer is called PTR, right? And there's our pointer operator with the asterisk. The value inside of it, when we set int pointer equal to var1 with the ampersand symbol, right? So if we were to do this, let me just draw it out for you really quick. If we were to do PTR equals, that's my ampersand, var1, then what would happen is it would be equal to the address. Okay, that's the value. But our pointer also has, for just, okay, if we were just to see out PTR like that, then what we would get is this. We would get 0x155. But if we were to do a, let me annotate one more time. If we were to do a dereference, okay, of our pointer, and we were to do a C, let me see, there we go, C out, and then we did our dereferencing operator, which is that asterisk, and then we dereferenced the pointer, okay, then what we would see on the console is this, 0x123. Okay, if you don't use that dereference operator here, okay, so if you just do this, this is the same code, then what you would get is this, 0x155. All right, and then we talked a little bit about creating pointers that instead of pointing to addresses in the stack for local variables, they point to addresses on the heap or in dynamic memory, which is kind of the same thing. One is available locally and one is created dynamically at runtime. Okay, you're using them the same way. The pointer will always point to an address. One is just on the stack and then one is on the heap. And the difference between the stack and the heap, you can kind of understand by watching that video that's in the week 10 weekly learning folder that talks about the stack and the heap. The only difference is the heap is used during runtime while your program's running. Okay, need in there. Whereas local variables, they might only exist for a little bit of time in the stack while that function is called, but then it disappears. Whereas our memory in the heap will be available until we release it. Okay, so this is just a brief overview of how pointers work. Hopefully this little diagram helps you out a little bit. Don't get too confused. Practice the slides, look over the videos, ask me any questions over email. Good luck, and we'll continue with pointers next week.